So this video is just going to be a quick refresher on calculating speed and also talking about the difference between the different kinds of speed and velocity. So let's go ahead and do a quick recap of just how do we calculate speed. So speed, again, is the amount of distance an object can travel in a certain amount of time. And we typically use this equation, speed equals distance divided by time. But there's going to be some cases where we know the speed of the object and we're trying to figure out the distance that they travel, or we're trying to figure out the time that they're able to travel. So this triangle is something that maybe you have already got melted into your brain, and that's good. And if not, maybe you want to practice that a little bit more. Or if you're a type of person that you're just like, I'm going to just memorize all the equations, you totally fine, float your boat, whatever. But let me explain how this triangle works one more time. So we have our original equation, like I said, speed equals distance divided by time. Now this horizontal line represents division. This vertical line represents multiplication. So if I am trying to find what the speed of the object is, and I put my hand or finger over the speed box, then I'm left with the equation distance divided by time. Let's say I'm trying to solve a problem where I need to calculate the distance that an object has traveled after so much time going a certain speed. If I put my finger or hand over the distance part of that triangle, then I'm left with the equation speed times time. Using that helps me to figure out what the distance is. If I want to figure out how much time has passed, again, put my finger over the time part of this triangle, and I'm left with the equation distance divided by speed. Now, a good strategy to kind of help you figure out your units for everything, or figuring out, is it speed I'm looking at, time, or distance, is to look at the units, right? So anytime you see something like meters per second or kilometers per hour, feet per minute, or miles per hour, anytime you see the slash or you see the word per, that's it's not a cat, it's talking about speed, all right? Notice that if you are given the unit for speed, then you're already given the units you're going to be using for distance and time, right? If speed was measured in meters per second, your units for distance are going to be meters, and your units for time is going to be seconds. Same thing with something like kilometers per hour, right? My speed is measured in kilometers per hour, so that means my distance has to be kilometers and my time has to be hours. It can also work the reverse way, right? Let's say I'm solving a problem where I need to figure out an object's speed, and I'm given distance measured in feet and time measured in minutes. Work backwards then. You know the distance is feet, time is minutes, so your speed is going to be measured in feet per minute. Or let's say, in another way, let's say we're given speed and distance, and we're like, what is the unit for time? Well, look at the speed, right? Miles per hour, time has to be measured in hours. So that's for calculating speed. Now you're going to be running into questions that says, calculate the average speed of the object. When you calculate the average speed, you are trying to look at the total distance that an object has traveled for an entire trip, divided by the total time that it took them, okay? Now, throughout this trip, we don't care, were you going fast, slow, did you stop and rest at any point? We don't care what happened in the trip. We only care about what was the length of the trip and how long did it take you to actually do that trip. Okay, that's average speed. If you get a problem that asks you about an instantaneous speed, that is the speed of an object at a very particular time. For example, a question could ask you, what was the speed of the object at 3 seconds, right? So you're going to want to know, how far has that object traveled in 3 seconds in order to calculate the instantaneous speed. More often than not, you'll be asked to calculate average speed, but just be aware that instantaneous speed is kind of like a speedometer. At a very particular instant, what was the speed? Now, in other questions, you're going to be asked to calculate the velocity, and don't freak out at this point. This isn't something new and different. The only difference is that you need to calculate the speed and then look at what direction was the object traveling. So an answer that would represent velocity could be the car was traveling 25 miles per hour north of town. We have a speed, we have a direction that they were traveling. Another example could be I walked 1 mile per hour backwards, right? Again, I have my speed and I have the direction that I was traveling. So for directions, you might see north, south, east, and west. You can also use backwards or forwards just as an indicator of what direction that object is traveling. Now, calculating speed is going to come into play quite a bit when we look at graphs. So if you don't feel confident with graphs quite yet, go back and review this first chunk that talks about position versus time graphs. When we get into the calculating speed part, that's going to be like, let me scroll down, like slide 15, right? We actually used the speed equation before we even really knew what it was in order to calculate that this pink interval was definitely going slower than the object during the yellow interval, all right? This on slide 14, this is another graphic that kind of helps you with that speed, distance, time equation triangle. All right, if you have any questions, don't hesitate to ask. Email or come to office hours.